Chapter 11 of Interactive Statistical Methods is a comprehensive chapter on statistical formulae, and this chapter appears to give you a large plethora of charts that show you the various ways in which statistical formulae, analytical, computational, and theoretical, mathematical variations in how a particular data construct such as the variance or standard deviation is represented. It also provides some guides for you if you're looking at post hoc tests, if you're looking at what is the measure that I want for a particular research design. So let's go through chapter 11, and this is placed here before the final chapter, chapter 12, which gives you more details on hypothesis testing. Takes everything that you've learned in the book up to now and wraps it together so that you understand the purpose, the workflow, the direction that you're going when you're putting together statistics and where it fits in the entire world of research and research design. So the chapter on statistical formula is pretty comprehensive. It starts off explaining to you summation notation, the analytical methodology, and then the computational mathematical calculative formula, and how the two are alike algebraically. So here we have the mean computationally, here we have the mean analytically with summation notation or sigma notation, and that the two are alike. One has more defining characteristics, the other quite simply has a notation for the calculations for the mathematics, but they're calculated in the same manner. Okay, statistical formulae tables. We start off with our inferential statistical formulae and looking at the measures of dispersion, the computational equation, the analytical equation. So this is more or less reviewing what you learned in previous chapters. What they look like, we've established earlier that they are equal, but there's different ways to calculate with them. Next we go into the population variance. Now here is a good example of the many different ways that you can find for a formula, a mathematical formula in statistics to exist for a single data variation. And of course we know the variance is the spread of the scores, if you will, in XYZ coordinates and the Cartesian coordinate plane around multiple Cartesian coordinate plane around the mean. Now look at the many different ways the mean in the variance in itself can be expressed. From the computational to the analytical to various other forms, both analytical and computation, they all give you the same thing for the mean. And then algebraically, you can jump in here and you can flip it a lot of different ways, but they all provide for you for a sample or a population, in this case population data, how you derive the mean. Excuse me, in this case sample, because we're using our S. But there's different ways you can derive your variance, your spread of scores around the mean. All of these will give you the same thing with that sample distribution. And there's more. It continues on the next page. So these are all provided so that you can understand that there's multiple ways to express a formula statistically, mathematically, but they're all giving you the same thing. So understanding the meaning is most important, because some people may teach it one way, some people may teach it another way, but when you know the basic meaning, you have a better understanding, and that's why these tables are placed in chapter 11, so you have that basic understanding. So I'm going to go through this very rapidly. There's every kind of table in here to explain from the reasons and rationales of why things occur the way they do, what proportions mean. It breaks down everything that you've seen in the chapter previously and some extra things you may see outside of interactive statistics methods to provide for you a comprehensive way of explaining how all of the workflow in statistics and research works. So if you have a question about a particular area in research and statistics, particularly that's dealing with mathematical formula and how you apply a particular formula, you're going to find it in chapter 11. It's really more of a reference chapter, but it's placed there so you can have a better understanding of how a lot of these things work. It's sequentially placed and it moves you through mathematical formulae, moves you through the rationale for formulae, why things are used the way they are, what is the formula, what is its definition, comprehensively, so you have a better idea of how this arena works and you're not confused in the future. If you do see a particular mathematical formula either defined or expressed using parsimony again with symbols, what it means, what it looks like. Getting a better level of comprehension of how all of this works. So as you scroll through chapter 11, go through it, read it, look at each table, read to gain a better level of understanding. Oh, this is why this is needed. You can refer back to the book index. It's going to give you even more examples, and it's going to help you to better understand why all these different terms are used and how they come back and are expressed mathematically and how they're used to express different criterion in the world of research and statistics. So as you read through, there's areas on degrees of freedom. So we're breaking everything down. I realize that a tabular format worked really well with those who are reading this text. And that concludes chapter 11.